Jungroo Learning is an AI-powered adaptive learning platform that uses artificial intelligence to personalize education, for each and every student. In this video, we'll see how Jungroo Learning's artificial intelligence, fondly called Prof Pi, works. Let us first consider the example of Ms. Dia. Dia is a grade 4 math teacher. She wants to know how good her student, Zia, is, in addition and subtraction. She decides to ask Zia a few questions, to test her proficiency. Dia asks the first question on the addition of two-digit numbers. Zia responds with the correct answer immediately. Seeing Zia answer correctly with confidence, Dia now poses the second question on the subtraction of three-digit numbers. Zia cannot compute the answer mentally. After a few minutes and a couple of attempts, she gets her answer right. So, Dia asks a couple of more questions, and through this assessment and observation, Dia identifies that Zia is pretty strong in basic addition and subtraction, but struggles when it comes to subtraction with borrow when zeros are there in the ones and the tens place. Like for example 500 minus 298. She needs to cancel two zeros and makes the tens place as 9. Dia clears Zia's misconceptions and gives her questions to practice. This entire process takes Dia about 30 minutes. Now, Dia wants to know the proficiency levels of all the 35 students in her classroom. She wants to know how good each of her students is, in computing the 4 math operations. As it is impossible for Dia to spend 30 minutes with each of her 35 students individually, she gives them all a pen and paper test. Each student is given a series of 10 questions on the 4 operations and is asked to attempt all questions. Based on their responses, Dia assigns scores to each of them. Through this score, she decides the proficiency levels of each student. Now, think about why Dia wanted to conduct the assessments in the first place. Dia wanted to know her students' conceptual and procedural level on a particular topic, and hence she conducted the written tests. Do the scores, obtained through the pen and paper test, give Dia the required information? Unfortunately, no. The assessment scores give no insights on the errors made by the students, or find the learning gaps at a very micro level, like three-digit subtraction with borrow with zeros in the ones and the tens place. It doesn't tell Dia why her students have made those errors. The assessment scores don't give insights on students' conceptual understanding. It cannot help Dia in identifying students' misconceptions, and supporting them, as per their needs. Thus, Dia's purpose is not being met, in this assessment approach. This problem is faced not only by Dia. Millions of teachers follow the pen and paper assessment approach to know about their students. These assessments cannot tell the teachers where the students are currently in their learning journey, and hence the teachers find it difficult to support the students as per their needs. We, at Jungroo Learning, aim to solve this problem. Our AI, Prof Pi, mimics the role of Dia to each and every child. Prof Pi locates exactly where the child is in their learning journey through adaptive assessments, and creates a personalized learning path for each child to master the concepts. Now, think about the assessment that Dia did with Zia. Based on Zia's responses, Dia deep dived into a few concepts, skipped a few, and reassessed certain concepts again. Dia was able to do this, because she knew the progressions and interconnections between the concepts. But what if a science teacher was asked to conduct similar assessments on math? He won't be able to conduct the assessments in a similar way like Dia did, because he may not know the interconnections between the concepts. Hence, to support him, we need to give him a concept map, to tell him how the concepts are interconnected and train him on conducting such assessments. Similarly, Prof Pi needs something called a knowledge graph. A knowledge graph tells the professor about the interconnections and the progressions in the concept areas. It helps him to conduct adaptive assessments. Prof Pi acts as a GPS here, and locates the students on this knowledge graph. He generates the most accurate learning path for each student based on their current position in the knowledge graphs, and helps them in reaching their destination of mastering the concepts. This is a sample knowledge graph, of grade 6 fractions. As the concepts taught in grade 6, are dependent on concepts taught in grade 5, the grade 6 concepts are connected to grade 5 concepts. Now you are seeing the sample grade 5 fractions knowledge graph. The grade 5 concepts are dependent on grade 4 concepts, and also on concepts in other domains like multiplication. Hence, the grade 5 graph is built, such that the concepts are connected, to both grade 4 concepts, and the concepts from other domains. As you see from the graph, the adaptivity in Professor Pi's assessments happen in both ways, across grades and across domains. In other adaptive assessments like GMAT, the adaptivity is only on difficulty levels. But, in Jungroo's AI, the adaptivity happens across difficulty levels and knowledge levels. This is one of the standout features of Professor Pi. Now, let us see how Professor Pi conducts adaptive assessments to create personalized learning paths. Namratha is a grade 5 student. We will see how Professor Pi identifies exactly where Namratha is in her journey of learning fractions, and how Professor Pi provides her a personalized learning path. This is the knowledge graph of grade 5 fractions. Each concept here is referred to as a node. As you see in the knowledge graph, grade 5 fractions has 2 top-level independent nodes. All the other remaining concepts in the graph are connected with these 2 encircled nodes. Through this graph, Professor Pi learns that if Namratha knows these 2 encircled concepts, then she should definitely know the remaining concepts. So, he starts the adaptive assessment by asking a question from any one of these 2 concepts. Here is the first question. It is from the concept, represent the given shaded portion as fractions. Namratha answers it right. She gets the second question on the subtraction of like fractions. Let's understand why Professor Pi chose this particular concept for the second question. As we saw, Namratha answered her first question right. So, Professor Pi moves to the other node. As you can see on screen, this node is dependent on 5 other concepts. In order to master the node, Namratha should know these 5 dependent concepts. So, Professor Pi checks Namratha in these 5 dependent concepts, one by one. This is why he asked the second question from the concept subtraction of like fractions. Now, let's go back to the assessment screen. Namratha answers it right. She gets the third question on compare 2 unlike fractions. Let's understand why Professor Pi chose this particular concept for the third question. Namratha gets the second question right. So, Professor Pi moves to the next one of the 5 dependent concepts, which is, compare 2 unlike fractions. Hence, the third question was from this concept. Now let's go back to the assessment screen. Namratha gets it wrong. She gets her fourth question from identify equivalent fractions numerically. Let's understand why Professor Pi chose this particular concept for the fourth question. Namratha answered the third question wrongly. Professor Pi makes a note of it and moves to the next dependent concept, which is, identify equivalent fractions numerically. Let's go back to the assessment screen now. Namratha gets this right. She gets her fifth question from the concept multiply 2d by 1d with regrouping. Let's find out why Professor Pi chose this particular concept for the fifth question. As Namratha answered the fourth question correctly, Professor Pi moves to the next dependent concept, which is, multiply 2d by 1d with regrouping. So, the fifth question was from this concept. Let's get back to the assessment screen now. Namratha answers this question correctly as well. So she gets her sixth question, from the concept, comparison of unlike fractions. If you remember, the third question that Namratha answered, was from this concept. She is being tested by Professor Pi on the same concept, again. Let us understand why. Professor Pi was observing Namratha's performance until now. She has answered all the questions correctly, except the question from the concept comparison of unlike fractions. Professor wants to find out if Namratha doesn't know that particular concept, or, did she make a careless error in computing. So, Professor Pi decides to pose one more question from the same concept, comparison of unlike fractions, to test his hypothesis. Hence, the sixth question was from this concept. Let's go back to the assessment screen to find out what happens next. Namratha gets it right this time. She gets her seventh question. Now, let's go back to the knowledge graph to understand what happened here. From Namratha's correct response, Professor Pi confirms that her earlier mistake was due to carelessness. Hence, he moves on to the next concept. Thus, by following the above process, Professor Pi identifies exactly where Namratha is in her journey of learning fractions, and provides her with a personalized learning path. This is how Professor Pi serves as a GPS for education. He locates each child at a micro level on the knowledge graph. As you saw in Namratha's scenario, Professor Pi's questions are not rule-based. He takes into account various factors like the guess, carelessness, responses to the previous questions, and adapts accordingly, in real time, to locate the learners, at a micro level. Thus, he is able to provide the most accurate, personalized learning path to each child, and guides them in their learning journey.